All right, guys, so this lesson we're going to start talking about multiplying polynomials. Last lesson you talked about what it meant to be a polynomial and the different kinds of polynomials we have. This time we're going to talk about what happens when we multiply them. We added and subtracted them last time as well, just combining like terms. You're going to see this is very similar to some stuff we've done before as well. Basically, when we are multiplying by polynomials, we want to think about using the distributive property. And one of the things we kind of want to keep in mind is that kind of like things will multiply. However, you can multiply any part of a polynomial together. It doesn't really matter. You just kind of only look at the things that are alike when you go to distribute. So if I go to distribute this, have this multiply here, and have it multiply over here, I'm going to multiply the 4 and the 3 together because they're alike, and I get 12. A and A we multiply together. Use my exponent laws, where this secretly has a 1 hiding out here. So a to the first times a to the second is going to give me a to the third. And then b to the second times b, again, there's a 1 hiding out here. So we're going to get b to the third. Okay, as you can see, when I'm multiplying, I'm kind of just multiplying the like things. We've kind of done stuff like this before. If you look over here, now I'm going to do 4a to the first b squared times 4b. The 4 has something to multiply that's alike. The other 4 over here. So I'm going to have plus 16. That's no problem. A has no a to really multiply by, so I'm just going to keep it how it is. Okay, nothing to combine it with, nothing to multiply with. I just leave it there. And the b is going to go to multiply, then b squared times b is going to be b to the third. Okay, after you multiply polynomials, you always want to check and make sure there's nothing you can add together, combine like terms. These are not like terms. Each of these monomials that are here are different. This one is a cubed, b cubed. This one's ab cubed, so they are not alike. We cannot add them together. Together, they form a binomial because there's 2 parts to it. All right, so that's basically how we're going to be multiplying our polynomials. Really not that bad, okay? I want you guys to go ahead and try these. Write these down on a piece of paper. Then come back and check with me and see if you got the same thing that I got. Try this one first. Number 1, 3k times 6k plus 4. And then try this one, 5x times 4x cubed minus x squared plus 7x. Okay, make sure you pause the video and then come back when you're finished to see if your work matches up with mine. All right, go ahead and take a look at what I did and check it with what you guys did. I went ahead and distributed here 3k times 6k and 3k times 4, 18k squared plus 12k. Again, there's nothing here to combine. They are not like terms. So this is a binomial, no like terms, so it's going to stay like that. Over here, end up with a trinomial 20x to the fourth minus 5x cubed plus 35x squared. Again, make sure you distribute that negative there. So 5x times negative x squared will be negative 5x to the third. Okay, check your work with what I did. Again, this is distributing something we've done before. So even though it's a little bit of a different application, it's something that we kind of already know how to do. Now, sometimes we just... sorry, guys, I just stopped there for a second. It might have been jolting. Sometimes when we go to multiply, we have to really be careful about the negatives that we have here. So when I go ahead and multiply this and distribute it through, I have a negative 5w to the fifth that's being multiplied. I'll go ahead and distribute it to the 3 things. Okay, so negative 5w to the fifth times w to the third will be negative 5w to the eighth. When I go and multiply with the next one, I got to remember I have 2 negatives. There's a negative with the negative 5 and a negative with this 8. So I got to make sure I remember that. 2 wrongs make a right in math class. I am now going to have plus 40w to the 7th. And then last but not least, I will go ahead and, sorry guys, my mouse is sticking here. Then I will go ahead and multiply by the last one and get minus 15w to the 5th. So again, you have to be really careful about your negatives when distributing, kind of like it was before. All right, so moving on. Review of GCF. Let's think back to when we talked about greatest common factors back in the year. This is going to help us for the next thing, talking about a really big topic that we're going to be covering in this chapter called factoring, okay? There's kind of 2 methods. There's either listing or our prime factorization. We can go through and we can just list out what are all the things that multiply to 45, or we can kind of break them down like we did a square root and try to figure out what the greatest common factors are. That's a number that goes into both of the 2 numbers listed. So for 45 and 60, my GCF is what's the biggest number that goes into 45 and into 60. So take a second to think about that. What is the biggest number that goes in each one? Again, you can either do that by breaking it all the way down or by just listing some factors and figuring out which one goes into both. If you went ahead and did that, hopefully you figured out that the greatest common factor is going to be 15. 15 times 3 gives us 45. while 15 times 4 gives us 60. So 15 is what we would call the GCF, the largest number that goes into both of these things. Now, GCFs are not only useful for numbers, they're also useful for different monomials that make up a polynomial. We can figure out what's the biggest thing that goes into each piece of our polynomial. Okay, so for case in point, let's look at this thing right here. 14a cubed b squared c to the 4th plus 35a squared b c to the 6th. I said find the GCF. This looks super complicated. It's really gross. It's got all these numbers and letters. We all know how much we love letters. It seems like something really hard to do. It's actually not. All we have to do is go to each piece and look for what is the biggest thing that is in each part of each of these monomials. So, when I look at this, if I look here, 14 and 35, that's going to be my number piece. I'll go ahead and I'll put a circle around these. So I know these are my numbers. What's the biggest thing that goes into 14 and 35? Well, we kind of can do what we did on the last slide, figure out a GCF, and I should get that 7 is the biggest thing that goes into both. I can then look at the next one. I'll underline this, A and A. I have an A cubed and an A to the 2nd. I want to know what's the biggest thing that goes into each one. The trick when you're dealing with variables is that you can just look at the exponent. Whatever the smaller exponent is, that is the biggest thing that goes into both. So for a to the 3rd and a to the 2nd, a to the 2nd is the GCF, the biggest thing that will go into them. I can do the same thing with b. I'll do a little squiggle here. And you can notice b squared and b is the smaller exponent. That can be what goes into both. And then with c, I have c to the 4th and c to the 6th. The smaller exponent is c to the 4th. Now, what does this have to do with factoring? If you remember way back in the day, we talked very briefly about factoring. When we talked about distributing, we said it was the opposite of distributing. Basically, it's trying to take something that you distributed or you multiplied and undoing it. How can I take it back apart to where it was before? So if you kind of looked at our last couple slides, if you go back, you looked at where we multiplied, we have something on the outside and then something inside parentheses that we distributed to. We basically want to revert this back to looking like that. If you're asking why are we doing that, you will find that out later this week or next week, okay? But it's really important to know how to do that. Looking at this, we can use a GCF as one way to factor. All we need to do is take our GCF and write it outside the parentheses. Now, luckily for us, we already found this GCF. So we can just recopy it down. And then we need to rewrite what's left over if we take that out. So inside our parentheses, we're going to take each of these polynomials and think about what would happen if I took each of these pieces out. So, for example, if I have a 14 and I take a 7 out, what's going to be left over? Well, 14 divided by 7 is 2. A 2 is going to be left over. You'll notice I'm basically doing the opposite of distributing. Instead of multiplying, I am dividing to figure out what's left over. That's what factoring is, the opposite of distributing. A third, if I take out an a squared, if you think of your exponent laws, you're going to subtract them. I'm going to be left with just an a. B squared, if I take out a b, if you subtract them, I'll be left with just a b. And then c to the 4th and c to the 4th, well, if I do 4 minus 4, I get 0. There really is not going to be any c term left here. That's it for this term. I can go ahead and put a plus sign here. There's a plus sign in between. And now look at this term. If I take a 7 out of 35, I'm going to have a 5 left over. A squared out of a squared, that's going to go away. 2 minus 2 gives me 0. B to the 1st minus b to the 1st, going to go away. 1 minus 1 gives me 0. C to the 6th minus c to the 4th is going to give me c to the 2nd. There is my factored version of this polynomial. In fact, I could check my work. If I distribute this back through, if I wanted to do that, I would actually end up back with this original polynomial. It's the opposite of distributing. We are factoring out, reverting back to that form that we had before. Okay, I want you guys to go ahead and try this one. Find the GCF of that, and then see if you can go ahead and factor it. It might be a little bit easier to do the top than the bottom. This one is a little more something that you've seen before. This is definitely a new step down here that's factoring out that GCF. But try finding the GCF, then try to factor it out. When you're finished trying, go ahead and check, unpause the video and check what I have and see if you agree with what I did. All right, if you're checking my work, you might be like, Mr. Guy, you tricked me. There was nothing that came out of the y or the z. That is okay. When you're finding a GCF, you are only taking the things that are in both parts of your polynomial in each term. So in this first term, 120 and 150, 30 is the GCF that comes out of them. X to the third and x squared is the GCF. They don't both have a y and they don't both have a z, so I don't need to worry about those. I only worry about the things that are shared between my terms. So 30x squared is going to be my GCF. I then go ahead and rewrite that on the outside. In the parentheses, I think about what would happen if I took a 30x squared out of each one. So to get the 4, I did 120 divided by 30, and that told me what I would get, 4. For the x, the reason why I got x is I did x cubed divided by x squared, which was my GCF, and I end up with just x. Think of your exponent laws. Y to the fourth, there was no y term being taken out, I just leave it. Same thing over here. Negative 150 divided by 30 will give me negative 5. X squared over x squared will get me x to the 0, which is 1. I don't need to write it. And then z, there was no z term. It just stays z. You can always check your answer again by distributing, and you will get the same thing that you started with. Okay? Here's 2 more for you to try. Once you try factoring each of these, again, you want to figure out what your GCF is. What is the big thing that can come out of each one? And then go ahead and figure out what would be left over if you took that out. Again, I'll give you guys a couple minutes to try this on your own. Pause the video and try them. Then come back to me and check and see if you agree with your answers. All right, if you factored each of these, is what you should have ended up with. Remember, on the outside of the parentheses, that's your GCF. So for this one, 5n was my GCF. It's being multiplied by 3n squared plus 5. If I take out that 5n from each one, that's what I would be left over with. Over here, hopefully you do your 9's times tables because all of these are multiples of 9. 9c squared is what's going to come out. C squared being the smallest exponent of my c's. So that means I have 2c to the third minus 7c squared minus 5 as what's left over after I take out that GCF. All right, so that is going to end this lesson on factoring in GCFs. Hopefully you guys kind of got a hang of what's going on here. There is another paper that it will be included here for you guys to work on. That's kind of like your practice for this. Again, the big things are to look for. What are those common factors? What are the things you can pull out of each part? You guys should kind of have an idea with the numbers. I know with the variables, it can be a little weird. But really, it's just looking for what's the smallest exponent you see. Whatever that is, that's what's going to come out. After you guys finish watching this video and kind of think you get a hang of it, go ahead and work on that worksheet for me. Again, make sure that you're keeping up with what's supposed to be going on at this point. You should have whatever's been assigned so far. Try to get that finished. Again, thank you for watching. I hope you have a pretty good idea what's happening.